Baseline.
So if someone tries to sue you for the output that you get from one of IBM's models running on Watson X, it means we'll come and we'll pay all those legal fees in court, uncapped.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human.
Make you question everything.
We keep seeing things online around mental health being at its worst point today. So maybe this type of technology can help. So I think it's at the same time, it's probably what's causing a lot of these problems. Technology is. So yeah, we'll have to wait and see. I think this is an interesting space.
It is. One of the conversations I've actually had today with Henry, it was about how, if you're going to present to someone, whether it's a sales presentation or any message, could be a health message, or if you're going to present a message to someone, you could, using generative AI, profiling their neurostructure about what is most appropriate for them to learn, and taking your messaging and running it through a GenAI to create a custom set of images, videos, content, language, spoken, written, whatever, in a way that's totally customized to optimize for their learning and their ability to ingest that data, which I thought was really interesting.
Yeah, so it's interesting you mentioned this. So as you know, I do teach AI. So I had an actual student also build something similar. She's working at Salesforce, I believe, and she looked after some sellers, and she wanted them to also have this certain pitch to different types and groups of customers, and to pull out different types of product information at the right time for the right person. So I definitely think it's an interesting use case for GenAI. But whenever I hear stuff like this is when my alarm bells start to ring, and I think this is probably what advertisers are using to target me in the same way with products that they see I might like. But at the same time, that might be good. Instead of me getting a random ad buying the latest new Mercedes that costs £150,000 that I can't buy right now, why not target me with something that actually makes sense?
I hate advertising. I hate advertising. There was a message I read the other day about ChatGPT starting to integrate. They called it subtle advertising. Like if there's any red flag, it's subtle advertising.
Okay, yeah.
Do you know?
Yeah,
and
yeah.
You kind of like take these closed AI models and solutions. You start to integrate them because they're so easy to use and the value is so high. What I don't like is if you think about advertising, it's pay to play. So whoever can pay the most is going to be preferred. So then you're in a situation where you have an objective assistant that you trust and has been extremely valuable that's now somehow subtly being manipulated by whoever's paying the most.
Exactly.
Which, like, for me, it's immediate. That's that technology I would not use again.
Yeah. And the thing is, you won't know when that's happening.
That's
because
subtly.
it's a closed system. You're right. And it's interesting, this week, OpenAI, they're doing their 12 days of Christmas, some marketing messaging once for the next 12 days. I don't know if you've seen this. And they've released their latest model that costs around, the new access tier that costs $200 now. So it's stepped up quite a lot from the $20 tier to now $200. So what's to say if you're a big enterprise using this technology or a small startup, that tomorrow they might change their, like you were saying, the algorithms in the back end, the systems and the softwares to target you and to infuse the models with some advertising or harsher tiers or some other limits. Now, I work at IBM, so of course I'll at this point use this chance to say we try to take a different angle at things. And I'm a big proposer for open source, only because I come from a software engineering background where a lot of the things I've developed on during my career has been on open source tech. So I think I can say this as part of IBM, which is use open source. Our Granite model is open source, and so you can actually go in, you can see how we've developed the model, you can see the data that we've used. And if you want, you can pick this up today, build a product around it, and it's yours because it's got an Apache 2.0 license. Now, where we would say for you to come and use it on our platforms, the reason is, we have all of these other great functionalities and features on watsonx that sit on top of Granite. But some of the key differentiators and the reasons we tell you to come on our platform is things like indemnification, which we can talk about, and some other bits and bobs that really give us a great foundation where you can put a model like Granite that's open source or some other open source model on top of, and then you can build vertical AI stacks that do some amazing things.
How do you envision the communities engaging with Granite? Because let's not forget, IBM's a publicly traded company that relies on revenue and profit.
Yeah.
And IBM has been known for a long time about highly proprietary, mainframe, enterprise technology stack, storage technologies, data protection technologies. And I totally accept, my experience of IBM over the last 10 years, we've seen a transition from proprietary to open. The acquisition of Red Hat. So someday, the DNA of IBM is changing.
Yeah.
But where's the revenue going to come from, Abdi? Where's the growth? Where's the business success going to come from that essentially funds the build out of the intellectual property that drives customer value? Do you know what?
So I think that's going to come from our wider platforms. So Granite is one small cog in a big machine. So because IBM, we have quite a lot of data and AI products, from databases to our data fabric, things to look at data governance. We really look at data and AI end to end. And Granite, for us to build a open source model, I think is part of IBM's history. If you really take a lens and you look at the history of IBM, you'll see we've been developing things and developing frontier models going back to the 80s, 90s. The only difference now is the market and the world has changed, where we can actually release some of these models in a place that has open source models. I think Hugging Face hasn't been around for more than a few years now. So there now is a place we can actually host some of these big models. And I think your question of how will IBM, at the end of the day, go to its shareholders and tell them, we're doing the right thing. I think it's around understanding that just because you have a model doesn't mean you can build a product around it. Like today, you can't take any model from Hugging Face on your laptop and you can write and connect to the model and get some answers. But to build a production system, to tune that model, to deploy it on a container, to have the full LLM ops, and to scale it up, you need a number of other services sitting around it. And that's what our platforms do. They really give you an enterprise-grade studio to develop models and to interact with models. It's not just here you go, there's Granite, you can do something with it. It's around how do you take it from having a model, the difference being having a model and having an actual system and a product you can sell to your customers or you can integrate with your products.
You're a great advocate of IBM, but if we just focus on the LLM race at the moment is really busy and fascinating to me. First of all, I think that I would like to talk about that.
Okay.
And then let's get into AGI and all sorts of things.
Okay.
Tell me what an LLM is. And let's talk a little bit about this number of parameters in an LLM.
Okay.
Because and I'd like to talk about Mistral and the new Meta release, which is fewer parameters, how the parameters actually turn into GPU burn and therefore cost. Could you just give me not just the IBM lens, but your lens on how that fits together?
Yeah, I do get this question a lot. What even is an LLM? Everyone keeps talking about it. So I'll try to summarize it down into two key components to how we get things like an LLM. The first component are these pre-trained models, aka foundation models. So these models have been trained on a wide variety of documents. So typically you can think of the wide web a company like, let's just imagine I'm trying to build my own OpenAI competitor company today. I'll go and I'll try to scrape everything on the web. I'll try to
These
get
are
as
general
much
purpose.
general purpose.
Yeah.
Yeah. So that's that first stage. And this concept of foundational models came around a few years ago from that. So we can understand what the English language is, and we can understand semantics in language, and we can understand concepts and locations and more. And that's that base model, that's step one. We then take it a step further and we do something called reinforcement learning with human feedback that takes these foundational models, these pre-trained models, and it changes them now to something that makes them good for conversations, an LLM, something that allows us to create a ChatGPT-like interface on top. And it's that conversational aspect that we're now training that base model to become good at. So if you try to have a conversation with that base model, it probably won't be good at answering your questions. We guide these base models that are really good at English and wider knowledge into now models that are conversational, that will understand you, that will understand your needs, that will actually fetch that knowledge, summarize it in the way that you need, and give that back to you. So that's what these large language models try to do. But whenever I teach this, I do try to say one thing, which is they're not magic boxes. The way to think of them is they are only predicting one word at a time. So you input some sentence, and all it will do is from that sentence that comes in, it will predict the next word. And then it just gets that word, adds it to the end of the sentence you've just put in, and it feeds that back in, predicts a new word. And then that sentence grows, and you get paragraph, and you get books. And that's where the magic is. These are just really good next word predictors. Now, there's lots of debate right now around, do these models actually have thought? And, are we going to get to AGI? Or are they just parrots? Are they just fetching information? Are they retrieval models? Are they looking at their database? Or are they actually coming up with something brand new? And I think this is a debate. There's really great papers and research on both sides now. And for you to test this yourself, you can talk to ChatGPT 4.0 model, and then you can compare that to the new 1.0 model, and you can see both have a different approach to answering questions. One is more of a retrieval type approach, and the other one really thinks. And that one really gets you thinking, maybe these models are like us. Maybe they are smart and capable.
What about the number of parameters? How does that affect is there an effect on quality or quantity? Why is the number of parameters is it a selling point?
You can think of the number of parameters really determining the size of these models. So typically now on the market, I think we have ones that are around 1 or 2 billion parameters, some around the 8 to 20, and then there's the really big models. So there's roughly these three categories. And they're really just showing you how big these neural networks that have been built up are. The bigger they are, it just means they've had more time to look at more data and to understand the data representation in a better way. I think if I try to summarize this down a step, which is all that models try to do is find patterns, and they're able to find they want to generalize something in your data so that you can take it and apply it to a new context. So the more parameters you have, the more multiplication that your network's doing, the bigger it is, the more it can capture, the more information it can capture, the more patterns it can know, the more use cases and things it can learn about that we stick into the model. Where a small model might be really good at just summarizing text, a large model might have more capabilities to understand things around the world, history, maths, and other stuff. So maybe try to think of it that way. Hope that helps.
Well, I kind of think of a bumblebee. It's got a limited set of actions. It kind of sees a flower, it flies over there, it kind of gathers nectar, it flies back.
Yeah.
It could probably be quite effective at its job on a limited number of instructions.
Yeah.
Because it doesn't need to think about how to get to the shops to do something and what's the impact of a train. There's a limited set of data points and stimulus that's going to affect its behavior, which I assume is a limited number of parameters.
Yeah.
But then when you get into much more complex, so if I thought about if an AI was running a traffic light,
Yeah.
it can probably get away with a relatively small amount of parameters.
Exactly.
If an AI was trying to diagnose a health ailment,
Yeah.
I'm thinking to myself, it's a much more uncontrolled, unlabeled environment. It needs a significant amount more data.
Yeah.
Does that kind of
Yes, exactly that. And that's why we have gotten to this point. Like if you go back all the way to the most simplest form of AI, you could think of maybe linear regression, which is something we all learn about in school. It's just a straight line and a graph that tells you as one thing grows, the other thing grows as well. So you have a very simplistic relationship between only two variables. And then throughout history, we've taken that and we've scaled that up. And now we are at the stage of we have these complex models that can somewhat represent language really well. But then the question now is, we want to get to AGI. We want to get even further. We want to get to something that really mimics our brains or something that's more powerful than our brains. And how do we get there? I think that's the next question.
as we're learning more about brains, though, we're realizing like brains are highly diverse.
Yeah.
In terms of, and I was thinking, as you were talking there about linear regression, I was thinking about psychological conditions like Tourette's. Assuming Tourette's is an actual condition where people, maybe shout a random word. And I'm thinking about how could an algorithm ever predict a random event and therefore replicate edge cases of neurodiversity? Do you see what I'm saying?
Yeah.
Because
yeah.
people will do things that are completely unpredictable.
Yeah, so this, I think, is the question of. So yes, humans are very unpredictable. We're very random, but so are these models. But they're only learning from what we're feeding it. So will they be able to understand and be as creative as humans are in the ways we are? Probably not today, but yeah, we'll probably move to a space where we learn more about what creates these different types of conditions, and then we use that type of approach in how we model our systems.
With the blockchain world, I always remember decentralization was around protection. But then there was this idea of a brute force attack where you would just take 51% of the available nodes in the network and kind of then engineer the network. If what you're saying is AI is learning from observed behavior, could you not brute force an AI by behaving in a certain way to almost teach it a set of but by behaving badly, you're teaching it to think that behavior is normal. So how do you make sure it knows that certain behaviors are outside of something that it should be replicating?
This is probably part of that pipeline for developing these models. So it reminds me of this interesting paper I read around like injecting things into the model so that it ends up doing things you wouldn't expect as well.
Or that you want to happen, but you're a bad actor.
You're a bad actor. And so the paper I wanted to talk about is from our friends at Anthropic, who released this paper detailing how you could actually set a flag at some point in the future in some data on the web. And if that's fed into a language model, at some future point, you can actually trigger it to release some code into as an output from your model without it doing anything today. So it's like a mine or some kind of a little bomb you can place in one of your competitors' models. And that's a big question now in the world of open source, because a lot of the large models on Hugging Face and other platforms are from countries like China and other places. So how can we really trust the wider open source community? So yeah, that's a very interesting thought. I also think these models, because they're trying to represent our brain, and the more we learn about the brain and the more we do in this space of building these complex models, the more similar they become. I remember listening to a neuroscientist talk about the brain and how all we do is our brains are building summaries upon summaries at each step of our brain network. And that's what these neural networks do today. So it's very similar how they work. So it'll be interesting to see where we get to with different types of conditions and mimicking humans. Now, will we want to mimic humans entirely? Probably not. because especially with these models, sometimes when we do that step of taking that foundational model and making them more conversational, the people that are doing that are these prompt engineers or these engineers that guide the model's output. So when me and you interact with ChatGPT, ChatGPT talks to us in a nice and friendly way. But the person who's guiding it is putting their own bias and their own influence into the model and really changing this base model that's really good at the concept of the English language and changing it a bit to become more like that person's worldview, which leaves me with two questions. The first question being, what if that person really likes commas? And this is something that some other papers have looked at around the structure and the output of how the model talks. We're going to get to a world where these amazing models have been diluted to become parrots of these handful of very smart individuals guiding the models. And then the second question that I have is around bias, around some of these models. How will it impact me being a young black man? If I interact with it, will I get the same outputs as someone else? And being an IBM, I'm responsible for putting some of this technology in banks and insurers, but also in companies that actually use this to analyze CVs and, categorize different people that are applying for roles. I also had a student do this. So one of my students in my course at BrainStation, they own this big company selling this small product. And they were telling me that they use ChatGPT to categorize the people applying for a job he posted on LinkedIn. Now, it's fantastic. I think it's a great way to actually use the technology. But is this technology actually safe in that way? And that's another question that I'm researching today.
There's a question there, because we've had a number of discussions on bias.
Yeah.
And one of the issues, obviously, with any predictive algorithm is the data it's been trained on.
Yep.
Right. And whether you like that data or not, if the data says a certain thing, it's whether we're comfortable that being a predominant rule.
Yeah.
Do you know what I mean?
Yeah.
So for example, if I was thinking, and the example we used was new drivers.
Okay.
If you go for an insurance quotation and you put your age in, and your age is 18, and all of the data says that an 18-year-old is 83% chance of crashing their car in the first 12 months.
Yeah.
Therefore, due to the 83% chance, we're going to increase your premium.
Yeah.
That's bias. That is a bias built on a data set. Whether we agree with the data set or not, what they're saying is the risk profile is higher with an 18-year-old. Now, all 18-year-olds could say, we're unhappy, we're being negatively assessed because we're 18, this is ageist, all these sort of things.
Yeah.
But the reality is 83% of 18-year-olds crash. I'm just making these numbers up, let's stop. I don't want a lot of people. So the question I would have there is that do we then say, actually, this is unfairly affecting 18-year-olds, so we'll change the data. Let's say we'll give 18-year-olds a 50% say because we don't want to be ageist, so we'll cut it to 41.5%, and therefore think. But the problem will be they'll continue to crash, and then nobody will get 18 because the risk profile hasn't been met. So my question is that how do you create objective data that we all agree is foundational data for something that, yes, is going to be biased? Because the idea of predictive analytics is itself making a decision based on past.
Yeah.
It's the question whether we agree with the past or not.
Yeah, and I don't think we can do that today.
But do you understand the issue?
I understand the issue, and I think there's potentially two ways to look at it. I think the first one is, yes, there will always be some bias. And I think of it similar to you're just setting rules for your organization. In that case, you just want to set a rule for, people between these ages. Let's put the premiums up a bit because, of course, they're the ones that are going to negatively impact how much money we have in our bank. But, I think the question comes more at when things are happening to a certain group of people without you really understanding why and without being aware of it. So some really interesting research has come out from Oxford, for example, where they were looking and analyzing ChatGPT, OpenAI's largest models and some of the other competitors, so Anthropic's models and some other open source ones. And they were able to show that these models weren't explicitly saying things to harm a certain group of people, but they had these implicit thoughts. They had these hidden thoughts that grouped certain types of people negatively compared to others. And if you look at it, the paper details two things. They showed how humans in the 40s, when they studied this at somewhere in the US, certain groups in the US, of course, had a negative impact in looking at Black Africans in the US. But that changed and became a lot more positive over time. They replicated that same study happening that they did in the 40s today, but with a language model. And the language model used a lot worse negative language against African Americans compared to other races. And I think the interesting thing they did then was they took it a step further and said, okay, let's imagine these language models in two settings. One being in a courtroom where they decide if someone's guilty, and another scenario where they are actually assessing the type of role an individual could have. And in both cases, they were negatively impacting a certain group of people. Bias will always be there, but I think it's around, if we don't tackle and we don't look at the impact it can have in other areas, then it can negatively impact a group of people without us even knowing.
So say, for example, if we were all trying to get into a football team,
Yeah.
and without watching our performance, it took up all of our football experience, which I wouldn't be getting into the football team, Abdi. So, but and it said, "You're not picked." Well, then I'm not going to like that outcome.
Yeah.
So how do you? Because I want to be on the team.
Yeah.
And it's like, but this reason, you're a certain height, and you play this way, and you do this, and there are a set of static data points would suggest you're not good enough to make the final squad.
Yeah.
Which I know they're using AI in. And in fact, this is, I think, something you've actually worked on, right?
Yeah.
So the point is, everybody who gets on the team will be like, AI is brilliant. It's basically made me. It's found my talent and put me in the team. We love this AI.
Yeah.
Well, hang on. The AI that hasn't, well, I don't agree. I should be on the team.
Yeah.
Therefore, it's biased. It's against me. It's against these data points. So how do we as people accept outcomes of non-human systems?
Yeah. For me, I think
Do you see? Because to your point, like, first of all, I would suggest there are probably lots of mistakes in data and decisions. So I have no doubt there are things that are happening at the moment that are completely inappropriate. But as we move forward, trusting machines more and more, how do we become to accept the decisions they make?
I think there's lots of angles to look at this, but I think for me the main ones are two: interpretability and explainability. If we can show someone that the outcome that they're receiving, if we can explain it, and if they can assess it themselves, and you give the individual the tools to do that, I think those are two things in my experience that's always very helpful. It reminds me back when I was in my first job at Legal & General. So back then I was doing lots of machine learning at scale, so building some different types of products and helping our actuarial teams analyze very complex data. The exam question there's two real main exam questions we had. One is, how long are people living for and why? And the second one is, how can we give them the correct products and price them in the right way? So you can imagine there's someone who's saved for retirement their whole lives. Maybe they have £1 million. They want to ensure that they're getting the best value for the money they've been saving their whole life. And I think in that case, if we have an AI system that just determines some price and tells them, hey, we'll give you £1,000 a month until you die, that's not what people want. They want to understand, yes, we've analyzed the data, we've understood who you are, and these are the reasons why we are giving you this total price.
It feels like there's a whole cultural evolution that would need to occur for everybody to start trusting in machines more.
Yeah.
But what there is a rule of law, and there are legal aspects to the application of AI in business.
Yeah.
So what I'm interested to know is, what you think the primary legal risks, and how are vendors helping businesses and organizations mitigate those risks or give them comfort in using this technology?
So I think that we can look at that in a number of different ways. I think the first one being, it really is similar to how you would productionize and sell and build any other data product. That's how I see it. A lot of organizations have ways of managing risks when it comes to traditional data science or machine learning workloads. And in that world, I think we need to take those base learnings, but only add on top now these new risks that come from the world of GenAI. There's definitely a few new things that we need to consider now. So as long as that's being wrapped and being governed and being looked at in the right ways, then we can productionize these systems and have amazing AI platforms and systems in production for lots of enterprises. But that does leave also that cultural questions. Will people use it? Will they trust it? There's so many cases now where individuals get an unfavorable outcome or they get promised something. For example, there's that famous case in Canada where the airline promised an individual some money for bereavement plane ticket. And that came generated from one of their new GenAI chatbots. And then the company said, actually, this came from, it just hallucinated this up. This is not our policy.
It was kind. It was
Yeah.
a kind AI.
It was actually a kind AI. But of course, the person who booked a ticket and was flying for a funeral said, that's not good enough. You've told me something. So they took that Canadian airline to court and they actually won the case. So now companies do have to, really think about how these AI systems are put out into the world. And I think it ties back to that interpretability, the explainability side of the world, the governance side of the world. You really want to govern these models in the right way. You need full accountability, full systems that are tracking these things, all the way from a lone developer or someone in the corner of your enterprise doing something on Excel with ChatGPT, all the way to those data science teams running multiple workloads on a large cluster somewhere. We need to have full view on all of those to do this properly.
So the state of, Granite, take Granite for example.
Yeah.
Are you comfortable now that Granite can be the language model to front customer-facing workloads?
So I wouldn't say it's Granite. So Granite, I think, is the technology that can help you get there, but you would need a governance product. And we have watsonx.governance, which is our enterprise way, enterprise product that sits around your AIs, no matter where you've built or deployed it.
So it's more than the language model.
It's more than
this
the language
is something
model.
that's analysing the actual. Does it sit as like a shim between what the LLM is producing and the customer? Is it like a filter?
So that's just one angle of it. So one angle you rightfully said is monitoring and being that safeguard of what's being sent to your customers. But there's three broader categories that this governance platform covers. One is making sure we're capturing all the information about these AI assets, whether it's one of these new GenAI applications, a model on ChatGPT, you might have that running in production, or something else. Just capturing all the facts as it moves from development to production. So that's one angle. The second angle is the ongoing monitoring and evaluation. And this is that safeguarding. So if you have an enterprise chatbot today on your website and you want to make sure no PII leaves some confined space, that's where you would want that ongoing monitoring and evaluation.
What would capture the airline's discount code? Where's that captured in a properly governed AI process?
So hopefully that would be governed both on the input and the output of the model. So you could potentially, and I'm sure this airline has this really complex architecture, but I think to really simplify it, as a request comes from a user into the system, you would want a way to just check and make sure we're not sending the LLM, or at certain stages, certain things don't get passed on. And likewise, as the LLM generates some content, if the LLM says, you're terrible and it starts swearing at your customer, you would want a safeguard there. So one example, but you can imagine you want that shield. So IBM, we as part of the Granite series of models, we have Guardian models, which is that shield, that protection step, and that fits into our governance platform as well. So yeah, definitely that's a second angle. Now, the last thing I'd mention that we also try to capture that's important in your AI life cycles is the governance at a higher level. So your governance and risk teams really need to have that oversight across your enterprise. Because me being a data scientist today, I've got a background doing some stuff on Azure, doing a little bit on AWS, some on-prem, some on my laptop. It's all great for me to be able to switch between all these new providers, and OpenAI might release something tomorrow that I want to use. But my product owner, my business manager, my team lead needs to look at everyone and make sure that every system that we're developing is being governed in the right ways. And that's another angle that the governance platform does.
It's quite rapid. It is rapid at the moment, I'm finding. I feel like there's something every week that's noteworthy.
Yeah.
It feels not necessarily volatile, but if I was an organization, I mean, I leverage all of the tools, Runway, Midjourney, ChatGPT, we're building stuff on Watson. There's a whole set of tools that in and out of, they're all evolving at different rates as well. I would say, like 1 week, if you come to video production, Kling could be ahead. The next week there's a new model, and then Runway's ahead. Runway releases camera control. Kling, it feels, the license models of just pay as you go feel right at the moment as you kind of use each product. The idea of an enterprise who has to commit, traditionally 3 to 5 year financial commitment. What is the process they would have to go through, without obviously just selling what you do, but is there a methodology to look at providers and go, we're comfortable with a 3-year relationship because of this volatility and speed of change?
So I think I'm going to give you a very short answer, and then I'm going to say, come talk to me if you want to know. Because this is my
you
day
are the
job.
consummate professional here.
Yeah, but I think I'll summarize it. It all depends. And I think that what I'm seeing a lot of customers do today is they are, like you said, moving away from very lengthy agreements because things are moving at speed. Like I was talking to a customer yesterday, and they were telling me that they completely switched the model provider they were doing earlier this month just because, Amazon started releasing models, so they thought let's use those instead. So I think we're going to see a lot of these enterprises for utilizing foundational models move to more of a shorter cycles, shorter contracts, and I think rightfully so, because this technology is changing every day. If today you do want something like a 3-year contract, then I think you really need to consider, okay, do I want to invest in a small startup who's only been around a year or two, or are there other questions that I need to consider, such as the legals, the support framework? So if something goes wrong next month and we find out that these models don't know the name of someone like ChatGPT, I don't know if you've seen the recent news where it just falls over if you ask a certain name.
Wasn't that person involved in some sort of litigation in the early stages, and they've completely removed the history. So
but it breaks ChatGPT. So what if you have that in the back end and your customer somehow asks a question similar to that name, and that breaks your production system tomorrow? Do you want to have a legal contract or some kind of a supply relationship with a vendor that's small, or one that's been around for many years?
Well, this leads me to trying to visualize architecture and how this stuff fits together, because I feel like the data is persistent, and the data that you're analyzing with AI, your big information repositories, whatever what you actually want to use as a vectoring or a training, that's persistent. It feels to me there's some pluggability or transience with the language models and the vendors. So in my mind, I start to visualize a different type of architecture, not one that is deeply embedded and integrated, that you have to massively capitalize investment and time and skilling, and then you're committed to.
Yeah.
It feels more, I mean, not microservices, but it feels more of AI services fitting into application architecture that you could change, or may even have 4 or 5 different AI providers who are specialists in certain areas, part of a single application or service stack.
Yeah. And I think that's definitely the way that LLMs are going, because there's just so many of them and everyone has their own version. So I think we are moving to a AI as a service model where you just pick a provider, you maybe click a button and say, today I want OpenAI's biggest model, but tomorrow you just switch that out with, maybe if you're an enterprise, Granite, because you know that's got that indemnification on all the enterprise features behind it. So yeah, you're definitely right. I think we are moving in a different way, which is different to how the world of AI and machine learning has traditionally been. A few years ago, it was that you'd need to do the full data science lifecycle, have a process of collecting data, building the model. Your data scientists would spend months iterating on that process. I spent a lot of time doing that, evaluated, and then you put that out into the world and you say, okay, you can use this for now, but probably after a month or two, we're going to have to go back and do this whole thing again, or maybe it's just modify the data that's come in. But now we're in a world where it's just these endpoints that are being continuously updated as the providers get more data or they get new architectures or new techniques to retrain their models. So yeah, very interesting.
So, and you've seen that evolve in your time. What do you think the next evolutions are going to be? What does the next 10 years look like in AI?
So a lot of people are talking about AGI, and I think we may get to a point where we have something very similar to AGI.
So just let's talk through what AGI actually is.
Okay, so it's, to really simplify it, it's just we want to get these AIs to a point where they have general intelligence instead of just being very good at one single task. In today's world, we have things like ChatGPT that you might think is general intelligence, but it's not really. It's just really good at language. It's good at answering your question by doing that single word prediction very quickly and sounding very smart. Now there are, we want to get to a point where instead we have these systems where if you were to ask it a question, it could reason and really think about what you're asking it, and it's not just parroting or mimicking what someone has written into its code. Instead, it's breaking down the question, coming up with an answer, and maybe doing different things. And I think the fear of AGI is one where it will just come and replace all our jobs. Because think of our traditional day jobs where we're checking the emails, we're telling our boss that we don't want to do X, Y, and Z and to give us a promotion and do all these other things responding to clients. A lot of that, I think, will be automated away with AI in the next year or two. And then at some point, we'll probably get to a world where these general AIs are so good at knowing more than language, knowing your domains of the world. So they might understand how to handle finances or to go and purchase something on your behalf. And when you bring these systems together, there's a question of what will we be doing? Even being creative. I think that was the thing people used to say a few years ago. AIs will never be creative, and AGI will come, but it will do the manual maths and all the other stuff. But today's world, we have these amazing models already, like Adobe Firefly, that can generate these beautiful images and beautiful videos, like OpenAI Sora model that was released this week. It can generate videos now, 1080p up to, I think it's like 30 seconds or something. We're going to get to a point where it can generate movies and create whole new worlds. And what will we do at that point? What will humans do?
AGI to me, and I had a conversation with Mark Patterson a couple of months ago, and it came very much around the idea of memory and a layer of memory upon the ability to predict language. Because if you think about our own decision-making process, a lot of it's shaped by memory and experience.
Yeah.
And I've even seen ChatGPT, as it remembers more,
Yeah.
its answers are more, they just feel more customized and contextual.
Yeah.
So it's pretending to get closer to actual intelligence as it frames language based on my personal engagements with it.
Yeah.
Then it makes me think, what really is intelligence?
Yeah. It's a very good question. And I think I've got a question for you. What if we do get to a point where, imagine we were able to scale up ChatGPT and it's just tracking everything you do and it's looking at everything you've done over the last 2 years. Do you think at that point it could create a version of you, a digital twin of you to answer questions and that would be you? Or is there more to you than just memory and the way you formulate your thoughts?
It's interesting, isn't it?
The soul, the question of the soul.
A lot of that is around persistence
Okay.
of behaviour, because you could say, if you could say within a micro situation, people are grumpy on a Monday morning. Let's just take that. Like, people are grumpy on a Monday. They've had a great weekend. They're back into work. Trains are running late. Da 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 da. So there's a set of contextual stimulation that Monday mornings. You could even say there are biomarkers. People have maybe consumed alcohol, or they haven't slept well. There's a set of things that would mean that you could predict people are going to be grumpy on a Monday morning.
Yeah.
And therefore, if we were creating a digital representation based on memory of me always going, why are all the trains always late on a Monday morning? But actually, I'd had a great weekend. I'd slept really well. The context was changed. Then it would again be create a version of me that isn't me, because it's built upon past profiles of stimulus, and not the contemporary one. So I think that if when I've looked at the characters and things, you probably get a middle of the road, greyish version of someone, and what you're removing is volatility. Is maybe a slightly negative term, but you're losing more of the spectrum of behaviour of a person.
Yeah. Yeah.
I don't know. It's going to be fascinating to see.
Yeah.
Finalise. I just want to come back to this legal point. How do companies protect themselves from these lawsuits?
Yeah. So I think there's two ways you can be protected if you come to IBM. The first one is with, the statement we've put out there, which is we give you the same rights you would expect from using any of our products, that full IP indemnification. So if someone tries to sue you for the output that you get from one of IBM's models running on Watson X, it means we'll come and we'll pay all those legal fees in court, uncapped. And I think that's a really powerful statement.
It's amazing.
Yeah. So if tomorrow, for example, a publisher tries to sue you and they say, what you've generated comes from one of our newspapers, IBM will come with our many lawyers, and we have a lot of lawyers, and we'll definitely come and ensure that, we pay any legal fees, and that even if you lose, we'll come and we'll actually cover it too.
But I have a question on this. Are you given that legal indemnity because you are a legal powerhouse, or are you given legal indemnity because the technology isn't going to misbehave?
I think both. I think some of our enterprise customers are so big that they will get sued by bad actors, and it happens all the time. So I think being a legal powerhouse is also an advantage. But the second angle that I think is the reason why we can put this out there is because we know how we've built these models, and that way is we've gone through the data, we've gone all the way down to each sentence, and we've categorized and grouped this. And you don't need to trust what I'm saying. We've released this in full white papers, so you can actually understand how IBM develops Granite. And it's a very interesting and fascinating paper. It's a nice bedtime reading. Right towards the end of the paper, we also talk about things such as sustainability, evaluation, how those things that we talked a little about earlier around the hate, abuse, profanity, and the governance side. We also detail some of that too in the paper. I think it's because we are more of the leaders in this AI ethics space, and to make sure when you release your AI models, you do it in the right way. It's more of you need an adult in the room doing this. And IBM is the adult in the room when it comes to AI. We're over 100 years old. A lot of these other startups in this space, your OpenAIs, your Anthropics, all the other ones, they are more focused at how can we build SOTA, state-of-the-art models, the frontier models. How do we get more compute, more data? They're not really thinking about those other questions. We have a big product, What's the Next Governance, that helps you with this. And we're partnered with AWS quite a lot. So there's great integration there already. So if you build something on AWS today, you can just govern it straight using our platforms. And I'm in constant conversation with lots of AWS customers, with the AWS teams actually talking about this. So I'm hoping if Canadian Airlines are watching this, we can have a conversation and we can help them not get into that trouble again.
You're at the forefront of this, Abdi. It's fascinating how you see this technology and talk about it, and it's actually very inspiring, I find. Especially, I like this fact that you come from a deep domain expertise in data science. That point in time where you decided not to build oil rigs and build data science, I think was lucky for all of us. But we've talked through a lot about indemnification, objectivity around language models, bias and human perception of decisions machines make. Do you believe AI is going to take us to a utopia or dystopia?
I truly believe utopia, and I think because of the impact this has had on my life. And whenever I talk to my students, there's one thing I always like to talk about, which is I think today's world, these AIs, they're really powerful at breaking down the academic and these worlds and institutions that had knowledge behind a paywall. Google was great when it came out, but there was still a barrier to getting the information you needed. And I think with these new technologies, we're able to quite quickly get vast amounts of knowledge within our phones. You could just talk to one of these models today. I think it's fascinating. I think I'm very hopeful as a person. So I think we will move towards a world where the whole world and all the different parts of the world, the global south, will also be able to use this technology and access information the same way I can here or someone can in California. I think if we get to that point, we'll just uplift society and humanity as well. Yeah.